Have you ever entered a building and felt like the place was fighting against the weather? Maybe it was just too stuffy or too hot or just uncomfortable. That is one of the reasons why building or constructing in response to climate matters. Now, wait, what is climate? Climate is the average weather condition of a place over a long or an extended period of time. It usually involves monitoring metrics like temperature, the wind, the rainfall, and the sunshine. Now, to go into the topic for today, which is climate responsive design, we'll take a definition. In simple terms, climate responsive design means constructing a building or designing a building in response to the weather, that is, the rainfall, the sunshine, the wind direction, or the temperature of the location where it is to be constructed. That means a building, that means one building design cannot be used for every location. The design would have to be shaped and adapted to match the location, the climate of the location where it is to be situated. For example, a building in a hot climate would vary greatly from a building in a cold climate. The goal is simple: make the building work. Before we continue, I would like you to take a few seconds to subscribe and like this video. One of the first things you consider in climate responsive design is orientation. What's orientation? Orientation is how a building is positioned in relation to the sun and the wind direction. As you well know, this affects how much heat gain a building experiences during the day, which affects how it performs at night. For example, a building that is wrongly positioned during the day would experience much heat gain, leading to experience of a hotter environment inside the building at night. But a building that is well positioned would not experience this much heat gain, therefore therefore leading to a cooler experience at night in a hot climate. Building on orientation, another important aspect we are going to talk about is ventilation. As mentioned in our last video on energy efficiency in buildings, ventilation is how fresh air enters the building and stale air leaves the building. For example, a building in a hot and dry climate can rely on natural ventilation, which involves airflow through windows and openings in the building to cool down the building. Without the need, this would reduce the need for active systems such as air conditioning or mechanical systems like fans. But in a hot and humid climate, it's a different ball game. The ventilation system of the building would have to be active or mechanical, which is use of air conditionings or fans or any other mechanical systems to cool down the indoor environment of that building. The next aspect is materials. Some buildings, some materials absorb heat and release this heat slowly than others. That is why, when designing, you have to consider the kind of materials you use for the roof, the walls, the windows, and different parts of the building, because all these play a major role in the use of energy in that building. Another idea is Another idea is shading. This is also very important because it helps reduce the amount of direct sunlight that gets into or gets to a building. It could be achieved using overhangs, louvers, balconies, or trees or shrubs. Basically, this helps to reduce the amount of heat that the amount of heat gain a building experiences during the day. Therefore, reducing the leading to less use of energy for cooling of that building. Why does this connect to sustainability? It does because a building, it helps reduce the amount of waste and energy use. A building that is well designed from the beginning would need less mechanical or no mechanical fixing later. That means less energy use, less cost, and more comforts for the people that make use of the building. So, sustainability is not just adding technology later, but also smart design from the beginning. If you found this helpful, please subscribe for more on sustainable construction. Also, please do well to leave a comment on your thoughts about using or employing climate design, climate responsive design tactics either before a building is constructed or after a building has been designed and constructed.